Very good morning, students. Welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the class 6th students for today's session. As you all well aware, and you can see on the screen, my subject is physics. We are in class 6th. Our ongoing last chapter, pressure. And today we are entering into the session number 4. So far we completed 3 classes in understanding the few important concepts of pressure. So we'll continue where we'll stop in the last class. But before that, let us recall what we learned in last 3 classes about the pressure, right? So when you move to the next slide, you can see these are the things what we covered in the earlier classes. You can see the pictures where you can see the pressure exerted by our knife to cut the vegetables, pressure exerted by liquid when the holes are made. There are the beautiful diagrams to explain about the pressure. Pressure of solids and pressure of liquid, which we already learned. So when you recall what we learned in the last 3 sessions, we learn about what is force. So what is the unit of force? It's nothing but Newton. Then what is area? What is thrust? Thrust is also a force, but which is acts perpendicular to the body. The perpendicular force is called thrust. Then we introduce about force, pressure, which is nothing but force by area or thrust by area. Depends on the in which direction force is acting. And formula we have seen, units also we have seen. What is the units of pressure? It is Newton per meter square or Pascal. Then applications of pressure, where the pressure can be applicable. So many places are there where we have seen applications of pressure. Then mathematical expression of pressure, which is given by P is equal to H rho G. The formula we derived, where H is the height, rho is the density of the given substance, and G is the acceleration due to gravity. Then we are discussing about the loss of fluid pressure in the last class. So after knowing about pressure, how many types of pressures are there? Downward pressure, upward pressure, sideward pressure, or lateral pressure. From that, we derived some important formula, that is loss, that we discussed in the last class. So today we are going to discuss about only one important topic, atmospheric pressure. The pressure exerted by atmosphere, that is nothing but air. So that we'll discuss in today's class, and how to measure that atmospheric pressure, how to measure the pressure of atmosphere. So thrust, pressure, applications of pressure, where we have seen so many examples in deserts, why the camels are having the legs different shape. As the area increases, pressure decreases. Okay, like that even army vehicles also. Then we have seen what is a fluid, both liquids and gases together called fluid. So both liquid also exert pressure, fluids also exert pressure, that is gases. Liquids pressures are of 3 types, downward, upward, and lateral. Sideward you can call it as. 3 types of pressures you can see in a single example. Then mathematical expression, H rho G. So loss of application, after knowing about the complete thing, we came to know the conclusion that on what factors pressure depends. It depends mainly on density of the substance and height, because G is constant. Those are called as applications, right? Loss. Now, today we are here to discuss about the last part of the chapter, or last part of the entire syllabus, atmospheric pressure. So what is atmosphere? Atmosphere is nothing but thick blanket of air. Thick blanket of air surround the earth surface. right? Around that surface, the crust, the thick blanket of air is surrounded. The thick blanket of air is called atmosphere. It may contain the air molecules, may contain the moisture, right? So there is summer, you can find the dry air, in winter, wet air, but all these are surrounded the earth. And the surrounding is known as, the surrounded air is known as atmosphere. So because of this, there is a pressure exerted by atmosphere, which is always act on everywhere. The atmosphere usually comes into play everywhere, wherever it is open. Such pressure is called atmospheric pressure. Pressure exerted by atmosphere. So what is atmosphere? Thick blanket of air surrounding the earth, right? That pressure exerted by atmosphere is called, second point, you can note, pressure exerted by atmosphere is called ATM pressure. You can simply write ATM, not ATM to take the money. This ATM is nothing but atmosphere, right? So thick blanket of air, you can note down as a synopsis of 3. The first point is thick blanket of air surrounded the earth's surface is called atmosphere. Is called atmosphere, in short form. Pressure exerted by that atmosphere is called atmospheric pressure, right? Same thing given here also. The whole earth is surrounded by a blanket of air. Blanket of air known as atmosphere. The atmosphere exerted up to the height of 1600 kilometers from the surface of the earth. So beyond that, there won't be nothing is there because vacuum is there. 1600 kilometers, you can find the atmospheric pressure. The weight of all the layers of air exerts a force on the surface of the earth. The force exerted on the unit area of the earth's surface due to atmosphere is called atmospheric pressure. So what happened? All these thick blanket of air exerts force on the earth's surface. So whatever is there on earth's surface is acted upon by this force. That force exerted by thick blanket of air over the earth's surface is called atmospheric pressure. Right? Clear? Very important points are given here. You can note also. Then standard atmosphere. What is standard value? It's normal, constantly. There may be some variation, but standard atmosphere is given here. The normal or standard pressure is average pressure of the atmosphere at a sea level at 273 Kelvin. The standard temperature. At that standard temperature, so is known that the pressure exerted by atmosphere is known as standard pressure. ST, standard temperature and pressure, you can call it as. Right? Atmosphere, that is pressure is 1 atm. At that time, it is found that 1 atm pressure can be balanced the column of mercury at 0.78 meter height or 76 mm, we can call it as 76 mm, 760 mm, 76 centimeters, 0.76 meters. This is a standard pressure, standard atmospheric pressure, right? 760 millimeters, 76 centimeter or 0.76 meters. So that you can find simple experiment. That is by manometer, barometer. So many are there. Thus, the normal or standard pressure is 0.76 of Hg. Because pressure is always measured with the mercury level. Hg is nothing but mercury. We are not aware of this because blood is our body exerts pressure which is slightly greater than the atmospheric pressure. Right? Our blood pressure is slightly greater than the atmospheric. Same. Suppose if blood pressure decreases and atmosphere is more, blood will come out, vomitings. Why will happen blood vomitings? Because of the inner pressure is more than the external pressure. Right? Clear? So this is about the We can express it in Pascal as 0. meters Hg pressure is nothing but 0.76 into, this is the density of the mercury. So it becomes 9.8 into 10 power 5 Pascal in Pascals. So you are multiplying with 1300, 1600 is nothing but density of mercury. H rho G, this is H rho G, 9.8. So you get 10.5 Pascal. 10.5 Pascal is the standard atmospheric pressure or 0.76 meter of Hg. So thus one atmosphere, you can note on the very important point, third point. Right? One atmosphere is nothing but 0.76 meter of Hg, 10.5 Pascal. How you got this one? 0.7 meter is the height. And density of the mercury is 30,600 in meters. And acceleration due to gravity is, so formula P is equal to H rho G. So what is the pressure? H is nothing but given height, 0.76 meters. So density is 13,600 kg per meter square into height. G is 9.8 meter per second square. Multiply this, we get the 10 to the power of 5. 10 to the power of 5 Pascal is the one atmospheric pressure. Right? Okay? Very, very important. Then, thus one atmosphere is 10.5 over. Right? Next, note, if the atmospheric pressure acting on a free surface, suppose free surface, maybe ocean, sea, or a bucket of water. Free surface acting on free surface of the liquid is also taken into account, then total pressure of the depth is atmospheric pressure plus pressure due to liquid. So when you are taking any surface of water, pressure also exerted on liquid because of the atmosphere, or two pressures will act on that. So you can take atmospheric pressure, PO, and pressure due to liquid is H rho G or HDG. Rho or D same only density. So total pressure acting on the surface of the liquid is pressure due to atmosphere and pressure exerted by liquid. Pressure exerted by liquid is given by HDG and pressure of atmosphere is P0. So you can add them, total pressure acting on the liquid will get. Keep bucket of water outside. And what is the total force pressure acting on the bucket is nothing but atmospheric pressure as well as pressure due to that particular liquid what you have taken in the bucket. Okay, clear? Now, uses, before going to see some videos, just we'll see the what are the uses of this. Okay, let us see the video, then we can discuss how this atmosphere pressure is useful for us in our day-to-day life. But before that, we'll go for one video on the same topic, that is on atmosphere. What is atmosphere pressure? How to measure it by using the barometer.
Barometric pressure, more commonly called atmospheric pressure, is the pressure exerted by the surrounding air in the atmosphere.
This is the definition. The pressure exerted by the surrounding air in the atmosphere is called atmospheric pressure, or it is also called barometric pressure because atmospheric pressure is measured with the barometer.
It gets the name barometric pressure because it is measured with a barometer. Barometric pressure is commonly measured at all weather stations. Why is this such an important feature of understanding our climate and weather? As it turns out, minor variations in atmospheric pressure are tied to changing weather conditions. In this lesson, we're going to examine the science behind barometric pressure. First, we need to understand what barometric pressure is and why it changes. In another lesson in this series, we learned that altitude and barometric pressure are closely interrelated. Atmospheric pressure decreases exponentially with higher altitude.
See, when you go to the height, up to 1600 kilometers, there is atmospheric pressure. But when you go from surface to the height, the pressure decreases. That is altitude, we can call it as.
Due to decreasing gravity with elevation and less overlying air pressing down. To incorporate all of the changes that occur with changes in altitude, the barometric pressure equation models the changes in air pressure with altitude. The barometric pressure equation is as follows, where P sub H is the pressure at elevation, P sub 0 is the pressure at sea level, M is the mass of one air molecule, G is gravity, H is the height at elevation, K is the Boltzmann constant,
That will come
and
across
T
the
is
exam.
temperature. What this equation shows you is that pressure decreases exponentially with altitude. As we see in this equation, barometric pressure is dependent on altitude, pressure at sea level, gravity, and temperature. However, I mentioned at the beginning of this lesson that barometric pressure can also tell us about changes in weather. You've likely seen local weather reports talking about high pressure and low pressure systems. Low pressure systems are associated with storms.
Right, anyway, I'll go for one more video. Is there?
Theory. In this video, we will talk about atmospheric pressure, specifically what it is, its units of measurement, and the instruments used to measure it. So, let's get started. First of all, let's look at what is pressure in general. Pressure is defined as the force applied on a surface per unit area, as we can see in its formula. In other words, we can say that it measures how an applied force is distributed over an area. With this in mind, we can affirm that the greater the force exerted over a certain area, the greater the pressure. And at the same time, the larger the area over which that force is exerted, the lower the pressure. Let's look at a couple of examples to better understand this relationship between force and area. Suppose that two people of equal weight are standing on a loose snow surface. Now, the fact that they both weigh 80 kilograms implies that the force they will exert on the snow will be the same in both cases. However, the difference is that the person on the left is wearing regular shoes, while the one on the right is wearing special snow footwear with a much larger sole.
Area is more. We can observe
With
it.
this, it is evident that the person on the left is distributing those 80 kilograms over a smaller area than the person on the right, who is standing over a larger
Larger
area.
area.
So, if we apply the pressure formula we have just seen, in the case of the person on the left, having a small surface, the pressure exerted on the snow will be higher. While on the other hand, the person on the right, standing over a larger surface, will exert
Area
less
more.
pressure on the snow. For this reason, the person on the left will tend to sink into the snow, while the person on the right will be able to walk more easily.
See,
So-
a beautiful example this is. Simple way, pressure is directly proportional to area. Greater the area, lesser the pressure. That is the reason when you are going for skating, we'll use a different type of made footwear. Whereas if you wear ordinary foot, it will sink into the, see here given clearly. Area is more, capital A is given here. Means area is more, area is less than the force. So his will sink, is will float easily, less pressure and more pressure.
Now that we have seen the general concept of pressure, let's move on to atmospheric pressure.
Now it is
But
our-
first, let's remember the main properties of air. As we said in a previous video, air is a fluid composed of various gases, and its main properties are temperature, pressure, density, and humidity. And although in this video we will focus on the pressure, we have to say that all these variables are directly related to each other.
Well, my sunscreen is lightweight, high protection, and has no white cast. Pick Sturma Shadow Sunscreen.
So with that being said, let's see what is atmospheric pressure. This is the force exerted by the air of the atmosphere on the Earth's surface, and it is produced by the weight of the column of air directly above a surface. Now, this concept may sound rather abstract, since in practice and in our daily life, it seems that air has no weight. However, the truth is that the air has mass, and therefore, the Earth's gravity causes it to have weight. This means that each air molecule exerts a certain weight on the Earth's surface, and therefore we can affirm that atmospheric pressure will depend on the amount of air molecules above a surface. Now, you might be wondering, if air has weight, why don't we feel it pushing us down against the surface? Well, the thing is that, as with all fluids, this atmospheric pressure acts equally in all directions. This means that it is distributed equally around all the objects inside the atmosphere, and this is the reason why we don't feel the atmospheric pressure. So, having understood the concept of atmospheric pressure, let's look at the units of measurement used for it. As we said previously, pressure is equal to force over area. Consequently, the units of measurement to be used must take this relationship into account. The International System of Units uses the Pascal as a standard, which is equal to 1 Newton per square meter. As we can see, a unit of force over a unit of area. However, in meteorology, to measure atmospheric pressure, the hectopascal is often used, which is equal to 100 pascals.
Hecto means 10.
However, the hectopascal is not the only unit of measurement used. Other widely used units are pounds per square inch, millibars,
Millibar.
inches of mercury, and millimeters of mercury. Here is a list of the most commonly used conversion factors between these
These are all
units.
the units of mercury. These are all the units of pressure, conversions. What is hectopascal is equal to how many pascals? Millibar, pascals, HP, hectopascals, everything is given. All the conversions from one system to another. Right.
Now, it is important to mention that in aeronautical meteorology, the most commonly used units are hectopascals and inches of mercury. And a general rule of thumb for quick conversions between these units is to divide by 34 to go from hectopascals to inches of mercury, or multiplied by 34 to go from inches of mercury to hectopascals. Now, another thing to keep in mind is that in some cases, you will see the terms hectopascals and millibars used interchangeably, and this is because these units of measurement are equivalent, so there is no difference between using one or the other. So having seen all this, let's move on to the instrument used to measure atmospheric pressure,
Barometer
which is the
used to measure the
barometer.
atmospheric pressure.
However, there are different types of barometers. In fact, we can classify them into two main types, the aneroid and the mercury barometer.
Mercury. Two
This
types of
last
barometers are there. Aneroid barometer and mercury barometer.
one is further subdivided into the fixed cistern or Q barometer and the adjustable cistern or Fortin barometer. Now, although we will not go into detail on the differences between these two variants of the instrument, let us look at the basic principle of operation of the mercury barometer. A mercury barometer consists of a vacuum glass tube that is closed at the top and open at the
Experiment
bottom,
you can do in
and
school
as we
also.
can see, the tube is partially submerged in a bucket or cistern filled with mercury. This way, atmospheric pressure will push the mercury in the cistern, forcing it up the tube, but at the same time, the weight of the mercury itself will try to counteract this. With this, the height of the mercury column depends directly on the atmospheric pressure. For example, if atmospheric pressure reduces, then the height of the mercury column in the tube will decrease. While on the other hand, if the pressure increases, the height of the mercury column will increase.
Changes.
Taking all this into account, atmospheric pressure can be determined directly by measuring the height of the mercury column in the tube,
760 mm.
either in millimeters or in inches. And actually, this is how the units of measurement of inches of mercury and millimeters of mercury
It's
were
very
born.
simple experiment. You can take mercury in one bowl and place a empty test tube. So we can see that it is raised to 760 millimeters or 29.92 inches. That is nothing but atmospheric pressure because of the sea. From both sides, atmosphere is acting on the mercury. As it increases, the level raises. As the pressure decreases, level fall down. That's what saying. Purely depends on the height only.
सनस्क्रीन नहीं लगाने से स्किन पर झुर्रियां, टैनिंग और झाइयां हो सकती है।
Fix Derma Shadow Sunscreen. रोज लगाओ।
This is Baba Now, and this is BB Now. Matlab Big Basket Now, delivering in 10 minutes.
So, now that we have seen how a mercury barometer works, let's move on to the aneroid barometer. This
Second type
instrument
of-
consists of a sealed capsule with a constant pressure inside. And it is designed so that atmospheric pressure can enter the instrument and try to compress the capsule. This way, the capsule will expand and contract depending on atmospheric pressure changes.
That is a
And
setup,
since this
complete
capsule is
arrangement.
connected by means of gears to the needle on the dial, the corresponding value of the atmospheric pressure will be indicated. And as an
In the
important
meter.
fact, this exact same principle is the one used by barometric altimeters, but instead of indicating the pressure, they are calibrated to indicate the corresponding altitude. So, with this being said, let's look at the barograph, which is an instrument used to record pressure changes over time.
Paragraph.
In simple terms, it uses the same principle as an aneroid barometer, but the difference is that it not only indicates, but also records pressure changes over time using a constantly moving paper. This instrument is very useful for identifying certain behaviors or pressure change trends within a certain period of time, and therefore allow for more accurate weather forecasts and models. We must emphasize that atmospheric pressure plays a major role in the development of atmospheric conditions, and it is therefore important to know how to read and interpret changes in pressure using the barometer and the barograph. Now, in general, we can say that at sea level, atmospheric pressure has an average standard value of 1013 hectopascals, 29.92 inches of mercury, or 760 millimeters.
Same only conversion keys. Either hectopascal or inch of mercury or mm of Hg. The conversions will be like that.
Of mercury. However, we must keep in mind that the pressure is constantly changing, and therefore these are reference values only. Actually, atmospheric pressure varies both horizontally with distance and vertically with altitude, but we will deal with that in a following video. I hope the...
So this is completely about the what is the atmospheric pressure, how to measure the atmospheric pressure by using the barometer. So barometer, aneroid barometer as well as mercury barometer, and also graph. By seeing graph also, as the pressure changes, the graph you can find the lines. By seeing that lines also, you can see the what is the pressure trend, how pressure is changing. Okay, trend of the pressure can be seen, right? Now that is about what we learned till now, atmospheric pressure. So when you see the uses here, when you come to uses, what are the uses of atmospheric pressure? Uses means where it is applicable in our day-to-day life, right? You can see here. Atmospheric pressure is used in the many of our things that we do. For example, when you drink water with a straw, the figure is shown here, while sucking, our lungs expand and air in the drinking straw goes into them. The air pressure in the straw decreases and the atmospheric pressure acting on the surface of the water. So due to increase in the surface atmospheric pressure, the water will enter into the straw and it goes to our lungs. Right. Then the force of the water to move up inside the straw and into our mouth. In the same way, atmospheric pressure forces a liquid to move into the syringe when you are going for injection. When it is plugged into the withdraw. Rubber suckers are used for installing the hooks in the kitchen and bathroom. The air between the rubber sucker and the wall is the first one. Okay, so these are all the applications where you can see first forced out so that the atmospheric pressure pressing on it can hold firmly against the wall, So atmospheric pressure measurements are important to meteorological. Meteorologists means those who study about the atmosphere, weather. For weather forecast, the unit of pressure used in the meteorological purpose is called the bar. Bar is the unit to measure the atmospheric pressure. A bar is the CGS unit of pressure equal to 10 power 6 dyne per square centimeter. Okay. So again, measurement of atmospheric pressure, we'll use the barometer. Barometer, just now we have seen. Barometer is the device used to measure the atmospheric pressure. Right. So this is totally about the atmospheric pressure. Atmospheric pressure is nothing but pressure exerted by atmosphere. So what is atmosphere? Atmosphere is nothing but a thick blanket of layer surrounding the surface of the earth. That air put pressure on the surface. That pressure is called atmospheric pressure, right? And that can be 760 millimeters of Hg or 29.36 inches or some other bar also, generally commonly measured in bar. So on all open surfaces, atmospheric pressure comes into act. And this is measured by a barometer. So we learn in next class more about the barometer. That is a conclusion part, along with some solved examples. You can see on the screen also, there are some measuring devices to measure the pressure exerted by liquid or blood pressure or air. So by this we learn about everything. Pressure exerted by solids, pressure exerted by liquids, and pressure exerted by atmosphere or air. Right. So we'll conclude this chapter. I'll conclude the syllabus in the next class. So you can practice all the questions for the coming examination, which is on 24th of this month. That is exactly the next week. Right. So that's all for today. So thank you, all of you. Have a wonderful day. Thank you.